A Guide to Addition at Moorfoot Primary. Pupils begin by learning to count. This would be initially to 5, then to 10, and then to 20. This is the foundations of addition. They may learn to count through practical activities and songs. You may find that as they're walking up the stairs in the house, they are counting the steps that they take. They may be counting how many cars they see on the road or how many cows they see in a field. This is all the beginning of addition. Pupils then go on to count forwards and backwards, starting at different numbers. The forwards and backwards, part of that comes into addition. The backwards we will talk about in another video about subtraction. So we start at different numbers to ensure that the pupils have a good understanding of what they're counting, and it's not just rote learning. At this point, we also ask them to recognise numbers. We show them in different styles, different fonts, so that they know that a 3 can be slightly different, but will still be the number 3. Then we look at one-to-one correspondence. This means that we ask the pupils to count again, but count how much is actually in front of them. So you might see some children counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but actually there's only 6 objects there. So one-to-one correspondence is making sure that they know they're not just counting up the way, but they're counting how much is there. So again, it's that check of it's not just rote learning, but that they understand what they're doing when they're counting, and that's really that next step. So from here, we would ask them to count objects and start at a different point each time. So if you had 6 cubes in front of you, you would ask them to count the 6 cubes, but they would maybe start at a different point. So this example here is one with some cat pictures. If you follow the arrow, you'll see what we are talking about. So if we started at this point, 1, 2, 3, 4, 5, 6, but this time we might move them around a little and ask them to start at a different point over here. 1, 2, 3, 4, 5, 6. We're trying to find some patterns already, so we're looking at maybe counting in rows or counting up and down the way, already looking to see these patterns for our next step. At this point, we would also introduce them to number formation so that they're not only thinking about what that number means and the value of the number, but what it looks like. Then we count out a given amount from a larger number. So for example, you may give them a large bag of pasta and ask them to count out 4 pieces of pasta. Now, the temptation is for them just to grab a big handful and give you them, but they need to count an individual piece. And it can be a little bit tricky the larger the amount because they're having to separate it. Then they would be looking at rearranging objects. So we're going to go into that a little bit later and looking at how we can look for patterns again. Okay, so moving on from rearranging objects, we're going on to looking at these patterns. So you may have heard of subitizing, and that's when our pupils need opportunities to see regular arrangements of small quantities. So how many are in these pictures without actually counting them? Now, one of the simplest examples of this is with a dice, because straight away you recognise those number patterns. When you're playing a board game at home, the children soon learn what the number 6 looks like because they're all desperate to roll a number 6. And that pattern of 3 and 3 is really useful for them to start seeing those number bonds. So 3 and 3 make 6. Or they may alternatively look at it along the way as rows. So 2, 4, 6. So that they know 2 plus 2 plus 2 is 6. They're beginning to see these patterns, which will be useful in addition later on. If we look at the number 5, you could ask them, how do we know this is a number 5? They may see a pattern of 2, 2 and 1. They may see a pattern of a 3 and a 2. They may have a different one altogether. Or they may just be able to simply look at it at this point and see 5. It's exactly the same with the 4. We see it as 2 and a 2. The 3, the 2 and the 1. So we're beginning to look for those patterns. Then we move on to when they're not in regular arrangements. So if we look over to this next one, we see a 3 and a 2. If we've started to spot that 3 and 2 makes 5, again, it's not in a regular arrangement like the dice, but we can see that it's broken into 2 pieces. We've got the 2 and the 1 here. Again, a bit similar to the dice, but we're still recognising it's a 2 and a 1, making 3. And over here we have the 4. So they're not in the regular arrangements, but can the children recognise that that's 4 without actually having to individually count? And it's good discussion to talk about why they know that that's 4 or 2 and 2 or 2 and 1. Then over here we can begin to see some dice patterns. We've got the 5 and the 4. When they begin to see that the 5 and the 4 is 9, then they don't have to count all the individual dots. And over here we are seeing the patterns of 3, 3 and 3, or they may look at it a different way. But again, it's trying to find those patterns to make addition easier so they're not having to count all the individual ones. And as you can probably see, that this early level is beginning to go into first level. At the end of early level going into first level, we're beginning to see pupils compare number and recognise which is larger. So there's 2 boxes, one which has 5 sweets and one which has 3 sweets. Which one would you rather have? So if, for example, they're seeing those in front of them, we could be using concrete materials, they would know straight away that 5 sweets was larger. So they're always going to want the larger number of sweeties, and this is a good way for them to be introduced to it. Also at early level is the concept of one more and one less. There are 5 frogs on the log and 1 more gets on. How many are there now? Then making predictions about what happens if I add 1 more. So you've got 4 cubes there. What would happen if I gave you 1 more? And then comparing 2 numbers and say which one is the larger one and why. We may use number lines for this so that the children can see that as we're gradually getting larger, that the numbers are changing. But we can also compare those with cubes. So we would have 5 cubes in front of us and 2 cubes. Which one is larger, and trying to explain why. So you can see that that progression is happening there. Okay, again, we're looking at subitizing here and the numbers on the dice. But now we're beginning to think about what other ways can we make the number 5. So we can make it with that 3 and 2 pattern we see here, or the 4 and the 1. Remember earlier we spoke about the 3 and the 2, or we might do 2, 2 and 1. Over here we might see this is 3 and 2. Down here the 4 and 1, or the 3 and 2. We might see this one as 5 and 0. So this is where really early on we begin to think about how we can make those number bonds. We also use at this point Numicon, and we get them to compare the shapes and what they look like. So we have a 10 here. What would fit on top of the 10? Well, there's a 9 piece that would fit on top of the 10, but there's 1 missing. So we would get the 1 piece and we would know that 9 and 1 make 10. This is how we would build up our story of 10 by simply using that base 10 as an example. We would do this for 5, for 6 and so on, just simply using Numicon. We may also use scales, and there's actually a Numicon scale which we use in school too, and it really is about balancing that out. So if we put 5 on the scale, which pieces can we add on to make 5 on the other side so that it balances out? That means we know it equals that answer. So 5 equals 3 plus 2 is just a different way of writing that sum that maybe we are used to, but it means exactly the same. And it's good for our pupils at this point, moving into early to first level, to see that the sums don't always have to follow the same patterns. But it's also good to use balancing scales as a way for them to understand that it's simply the same on either side, and that you need to balance it to find what number makes 5. We then reinforce number bonds using concrete, visual and abstract. What do we mean by concrete, visual and abstract? Well, concrete is your cubes, your Numicon, pieces of pasta, anything that the pupils can pick up and play with. The visual is a drawing, so we've got some apples here, and we've got 2 different coloured apples so that we know we're adding the 3 and the 2. We could add some pictures of dinosaurs. It can be pictures of anything at all, and that helps our children to see a visual representation of it. And we also use this here, which has these circles, so we know that 2 parts make that whole of 7. What are the 2 parts? And also visual could be as drawing out the scales, and concrete for the scales would be an actual set of scales with the Numicon pieces being weighed out. And the Numicon pieces also are weighted, so it would work with actual concrete materials as well as a visual. The abstract is the sum. So just writing that sum, 5 plus 2 equals 7. If it's vertical or horizontal, it's still the abstract. So we need to make sure the children understand it concrete. That's why they do lots of playing. And then the visual, so they're writing out the sum but using pictures like apples. And then the abstract, where it's just a sum and we've taken all the other things away. And we hope by that point that they have that confidence from the others, concrete and visual, to really understand what the abstract means. So we're not just simply asking them 5 plus 2. They have in their minds that it would be 5 cubes plus 2 cubes. They have in their minds that visual of the 3 apples plus 2 apples. It's beginning to see the link between the numbers. Going from early to first level, we would also begin looking at 10 frames. So a 10 frame is simply a rectangle that's been cut into 10 equal pieces. And you can see that there, they've all been divided into 10 pieces. Now in school, we would print off blank ones and use counters, or occasionally we would print off ones that are already got the counters added to them. And this is a bit like the subitizing from earlier. We want those children to recognise those patterns. So this one here, we would know straight away that the 10 frame, we would teach them that they have 10 spots at the top and 10 spots at the bottom, or 10 boxes, so that they know that it's 5 on the top and 5 on the bottom. So straight away they can see that picture of 5 counters. They don't need to count. They know there will always be 5 there. So actually all they need to do is count the bottom. So they would be starting at 5 and counting on, or they know it would be 5 and 3. Another thing to point out here is the fact that they would know this is 3 because they know it's 5 on the top and 5 on the bottom. They know there's 2 empty and that 3 and 2 make 5, so it's just an additional way for them to be reinforced that this is 3 without them having to count 1, 2, 3 or 1, 2, 3, 4, 5. We're really getting them to think about those patterns, and it's another way for them to think about the number bonds. This one is always going to be 10, so if we have 8 counters here, we know that 8 and 2 is going to be 10. It's a bit similar to if you were using your fingers. You know you always have 10 fingers, so if you were to hide 2 and there was 8 left, 8 and 2 would make 10. It's just to try and reinforce those number bonds because that is the basis of so much of our math. This one over here is slightly different. We have it turned on the other way, and that's really to begin to see those number bonds as 2s. So rather than simply counting 1, 2, 3, 4, 5, 6, 7, 8, at this point we would begin to encourage them to count in 2s. And that fits in with our multiplication video because counting in 2s is addition, but we know that addition is the first step of multiplication. So we would be encouraging them to count up in 2s here, and straight away they would know that the 2s would make 6, 2, 4, 6. Or if they were counting in 3s, they would have a 3 here and a 3 here, so 3 and 3 make 6, or 2 plus 2 plus 2 makes 6. Again, they would know 5 down this side, and they would know that there was 2 missing. So what they could do is, if there's 2 missing from the 10 frame, they could count back. So starting at 10, count back 2 jumps, would give them 8. So as you can see, the 10 frames are really useful for reinforcing those number bonds and making them think a little bit more about numbers. The next thing that we often use in school is a Reckon Rec, and this is an ICT version of it, but we have the actual physical ones in school, and they may remind you of an abacus. As you can see, they are coloured and they're also in sets of 5, so therefore they're also in sets of 10. Now, what we tend to do is use this for number bonds and patterns, a bit like the subitizing. So the pupils always know there's 5 red and 5 white. So if I was to take over 3, we would know straight away that was 8. We wouldn't have to count up all of them to know because 5 and 3 is 8. Or we could bring over all of these. We know that there's 10 altogether on that top line. There's 1 left over, so it must be 9 because 1 less is 10. Then down here we've also got some more that we can look for those patterns. So if I was to use 2 over here and 2 over here, it looks a little bit like that dice pattern, doesn't it, from earlier? So we know there's always 5. We'd count up in 5s, 5, 10. Here we have our 4, our pattern of 4, very similar to our dice. We're hoping that our pupils would recognise this at this point. So we'd have 4 plus our 10, which is 14. But we'd then draw their attention to the single ones up here. We know there's still 5 and 2. 5 and 2 is 7. So 7 plus 7 makes 14. We're beginning to see those patterns now. We might do the same if it was a larger number, but this time we may not have it quite as easy. Okay, we're going to have this, and as you can see, the arrangement's a bit spread out. But we know here that there's 5 and there's 5. We can count, we can see that they look almost the same on the lines. So it's 3 and 3. Or what we can do is, we know there's always 20. How many are over here? It looks like that dice pattern again, doesn't it? So we know there's 4 over here. So if there's 4 less in that, then that would give us the answer from away from 20. So what is 20 take away the 4? We could count back those 4 jumps. Or we can know that there's 5, 5, 3 and 3. So what would that be altogether? Well, 5 and 5 we know is 10. Our 3 and 3 is 6. So it'd be 16. And again, we would go over things like the 5 and the 3 makes 8, so 8 and 8 makes 16. We're trying to get that reinforcement there of those number bonds, and that's why maybe you'll have heard your child talking about a Reckon Rec, and we'd recommend you to use this site. You can see it here, or if you just Google Reckon Rec online, that will take you to the same page. So the next step, moving on from early to first, would be using a number line. We would be counting the jumps here. Now, they will be exposed to this at early level, and at first level there would be more challenging questions, so you can begin to see that progression. So let's have a look at the number line and what we mean by jumps. So if we had 4 plus 5, I would start down here at 4 and I would move on 5 jumps. 1, 2, 3, 4, 5. It's really important that we speak about jumps rather than just adding on 5, because what happens is quite often the boys and girls start at 4, so they'd go 1, 2, 3, 4, 5, but we know that that's not correct. We're not counting the number we're on. So it's really important that we count the jumps 1, and it's that physical movement at the beginning that really helps them. The next step at first level would be to hold that number in your head. So you might see your child at the beginning, if they've been given a question like 4 plus 8, they might go on the number line and count 1, 2, 3, they'd maybe have 1, and they'd count their jumps and they'd find 4. Or they would count on their fingers 1, 2, 3, 4, and they would get that 4 in their head. Or they would go and they would get cubes and count out the 4. But the next step for our children is to hold that 4 in their head and keep holding the 4 in their head without getting 4 cubes, without counting 4 in the number line, and just counting on. So if they had the 4 in their head, they would count out 8 cubes, 1, 2, 3, 4, 5, 6, 7, 8, and then they would take the 4 that they've held in their head and they would just start counting on 5, 6, and so on. That still worked for the number line. They would find the 4 straight away and they would just count their 8 jumps. And then that would give them the correct answer. Then they would move on to reversing it. So always start at the larger number and count on the smaller number because it's going to be quicker. This takes us on to the next part, which is some strategies for addition. So we want the pupils to recognise that 1 plus 9 is the same as 9 plus 1, and that's reinforced through their number bonds, because when they're learning number bonds, they'd learn 6 and 4, 4 and 6. They would also go into doing doubles. We spoke about counting in 2s earlier, but we would also do doubles, so 3 and 3, 4 and 4. It is the beginning of multiplication, but it's also the beginning of addition. Once they're secure in their doubles, they can begin to use near doubles. So instead of doing 5 plus 6, 5, right, let's start counting on 6 or get 5 cubes and 6 cubes. If they know 5 and 5 is 10 and that 6 is made up of 5 and 1, then they can double it and add 1. And quite a lot of pupils find that really quite a quick answer to finding out these more tricky sums. We also have a system called Best Friend 10 or bridging. And that goes back to those number bonds that we've really reinforced. So an example, 7 plus 4. Rather than doing 7 plus 4 and counting on, using your fingers, using a number line, using cubes, what we would do is ask the pupils to hold on to that number 7. What do they know about that when it comes to adding to 10? Well, they know 7 and 3 make 10, but they also know that 4 is made up of 3 and 1. It goes back to the number bonds. So rather than counting that up, they just go straight to 10. How much have they used to add on to get that number 10? Well, it's 3. How much is left over from the 4? Another 1. So we add 3 and then add the 1 to 7 rather than just jumping straight to adding 4. So that number 10 really is important, and it comes back when we're using 20, we're using 100, using 1,000. It's to see those connections. Okay, then we're going to go on to looking at some written sums. Oh, there we go. So once the child is confident with addition, then we move on to the formal written methods. Remember, we were speaking earlier about concrete and visual and abstract. Well, this is the abstract part, and we want our children to be really secure before they go on to this. So you may have seen them using lots of different concrete materials. You may have seen them using hundreds pieces being made up with 10 tens, or they may have been using 10 cubes, so that they understand what we mean by units, tens and hundreds, because it's really important that they know that it's not just simply 5 in this column, but it's 5 hundreds. It's not just 4, but it's 4 hundreds. So this one's quite a straightforward one to do. We would just add 2 and our 7. We would use those number bonds again to know that it's 9. 6 and 3 would be 9, and 5 and 4 would be 9. That's a nice easy one. But of course we've also got carrying. So let's look at how we carry. We've got the 5 and the 9. When we add those two together, we get 14. This is a point where sometimes our children get mixed up. But if we write out 14, we know straight away it's 1 10 and 4 units. So the 4 must stay in the units column. The 1 must go to the tens column. 9 plus 9 plus 1. We know again that that is 19. I would recommend them using their number bonds for that part. So the 9 and the 1 straight away they recognise as 10. So it would just be 10 plus 9. Again, we know that's 9 units and 1 tens. We put our 9 down and we carry the 1. 6 plus 5 plus 1. Again, I would use my doubles. So 5 plus 1 is 6. And I know that that's 12. And I would begin to talk to the pupils about why that 12 looks slightly different and it's going into a new column, because we have our thousands. And we're now going into that new column there. Now, as I said, we would use these materials at the side here for them to be reinforced. What we mean by hundreds, that's a full 100 square. What we mean by 10, and these are 10 base blocks. And what we mean by tens, 100 and 1,000, and then those individual cubes. It's really important for our children to see what those visually look like, and it helps them understand when we're doing these sums. So we don't want our children just to jump straight onto this. We want them to have a really firm understanding. Okay, from first to second level, you might find addition strategies are quite similar. So again, we might be reversing those sums. Remember we said earlier, start with the larger one and add in the smaller amount. Those near doubles and doubles, so 2,000 and 2,000, 24,000 and 24,000, they begin to see these patterns because it really is the thousands here that we're doubling rather than the full thing. Near doubles, if we know 500 and 500 is 1,000, then we know we're just adding 1,000 plus 100. Reordering, so we have 23 and 54. Rather than simply adding up the two numbers together, we might add the 20 and the 50, then the 3 and the 4. Looking for number bonds, as we've mentioned before, that 6 and 4 straight away should jump out. We know that's 10. So all we would have to do there is add the 40, the 50, then the 10. And the children found it much easier to count in tens. Making connections, 80 and 70, think about 8 and 7, think about those number bonds again from earlier, or think about your best friend 10. How would you add up 8 and 7? You would add up the 2 from the 7 and then the 5. So it's going back to those best friend 10s. And we would use that again here, 877 plus 104. We'd think about the 7 and the 4 if we're adding those two together. Let's add the 7 and 3 first to make the 10. And if the 4 is made up of 3 and 1, we're just adding on a 1 rather than simply adding on the whole 4. So the 3, then the 1. So 877, we would just add on the 4. Rather than just add on the 4, we would add on the 3 and the 1. So that would take us up to 881. At first, going into second level, we would be also looking at number lines and number squares. So for example, we might have the number 65 plus 8. We would encourage the children to do a couple of different things here. At first, we might ask them to start at 65 on the number line and just make 8 jumps, the way we were talking about earlier. But we can also begin to look at some patterns here. So if we had 65 over here, rather than adding 8, we could add on 10 and count back 2. So we've got 65, let's add on 10 and count back 2. If the children have that real security of understanding that 8 is the same as 10, take away 2, then they'll be able to use some shortcuts in this because, again, the children find it easier to count in tens. The same would happen with 65 plus 28. We'd start at 65, we would add on the tens column and then the units column. We were talking about breaking that up earlier, and we would do the same if we were using a number square. So 65, let's add on 20. That would take us to 85, and then we would add on 8. Now, rather than adding on 8, we could add on 10 and go back 2. So we'd add on 10 and jump back 2. That would be the same if we were adding on 9. You could say jump over 10 and go back 1, because we know that 9 and 1 make 10. It could be the same with 7, so we'd add on 10 and count back 3, because we know that 7 and 3 make 10. It's about using those patterns to help our children learn to do things quickly and to have a great understanding of what we're talking about when we're doing addition. Okay, so one of the other ways we would look at this is partitioning, which we've kind of touched upon already by breaking up the numbers into smaller pieces. So if we had 285 plus 174, we would break that up into our hundreds, tens and units. So let's look at adding the hundreds first. We would take the 200 and the 100 from the question, then the 80 and the 70, so we're doing the tens column, then the 5 and the 4. Then all we have to do at the end is add it all up together, and it's a much easier sum to do. When we do it this way, we give our children a greater understanding of what we mean by 285 and 174. We give them that greater understanding of place value, which is really useful in maths, and it's important that they have that understanding before they go on to the addition sums. We can also do partitioning with a number line. We're going to break up the 174 into smaller pieces that fit the number line. So straight away, I'm going to add in my 100. That takes me to 385. How would I get up to 400? Well, I'd add on 15. And then I would take, so we're still at 115 here. We need to get to 174. I'd add on 50. So that would take us to 450. And so far I've only added on 165. We know that, 100, 115, 165. I've only added 165 on, and we've got to 450. I still need to add on my 9, and that would give me 174, and it would give me the final answer of 459. So you can see that that is a different method, and it might make sense to some people to writing it down rather than simply adding up into stages. Okay, we also have